In today's video, we're going to be exploring special products. By the end of this video, you should be able to square binomials that result in perfect square trinomials, find the product of a sum and a difference that result in a difference of squares, and then you should be able to apply these special product patterns to word problems. Here's our key terms. So we have perfect square trinomial, so it can take two forms. It can be in the form of a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. And it's the result of squaring a binomial. For a difference of squares, it's an expression in the form of a squared minus b squared that involves the subtraction of two squares. Let's get started with our first learning goal. Now, there's two options we have when we square binomials. So, oops, my apologies, 1 second. My bad, y'all, for this botchy video. Let me get it back on track here. Okay, so squaring binomials. Okay, so that's like a plus b squared. So as I was saying, you could use algebra tiles, or you could use the patterns. So we're going to use patterns for this, and I'm going to give you the steps of how to do this. We're going to write out all the steps, and then we'll jump into an example. Okay, so what you're going to do first in step 1 is you're going to square the first term. Okay, and then in step 2, you're going to find twice the product of the terms. So that means you're going to can I fit this underneath here maybe? That means you're going to multiply the terms together, then multiply by 2. Okay? And then step 3 is we're going to square the last term. Okay, so let's do an example here. I'm just going to make this a little bit thinner. Okay, so example. So let's say we have a plus b squared. So what we're going to do is, if we follow step 1, okay, so we have to square the first term. So if we square the first term, which is a, we're going to get a squared. Then for step 2, we have to multiply these two terms together and then multiply by 2. So I have to take both of these terms. I don't think you can really see that. Maybe I'll draw an arrow here instead. Both of these terms, multiply them. So what's a times b? A times b is going to give me ab, and then I have to multiply that by 2, so that I'm going to get 2ab. And then I have to do step 3, which is, get a different color, square my last term, b squared. That's it. we can do the same thing to create a perfect squared trinomial. And what happens is the middle term here, I don't know if you noticed, depends on the term inside the brackets. So that means this middle term here is going to be plus if we see plus inside the brackets, and it's going to be minus if we see minus inside the brackets. So let's do this one. Let's follow the same step. Step 1, I'm going to square the first term, so I'm going to get a squared. I check to see what's inside my brackets. I see it's a minus, so my middle term I know is going to be minus. And then I follow step 2, multiply the terms together, then multiply by 2. So I'll multiply them together, I get AB, and if I multiply by 2, I get 2AB, and then I square the last term. So the result here are perfect square trinomials. Okay, so let's try following these steps with an example. So let's say I have x plus 3 squared. So step 1, I'm going to square the first term. So I'm going to have x squared. I know that I see a positive in here, so I know my middle term I'm going to be adding. All right, so let's follow step 2. I'm going to multiply the terms together, so I get 3x, and I'm going to multiply that by 2. So I'm going to get 6x. And then I'm going to square the last term. 3 squared is 9. You can also think about this in a different way. This is just really x plus 3 times x plus 3. If you were to do FOIL, you'd get the same answer, right? X times x is x squared, x times 3 is 3x, and then 3 times x is 3x, and 3 times 3 is 9. If I simplify, I get x squared plus 6x plus 9. That could be a way for you to check. I just realized I had the wrong learning goal up here. Okay, sorry about that. We're still squaring binomials, but now we're going to move to learning goal number 2. Okay, so moving on to our second learning goal, we are going to find the product of a sum and a difference that results in a difference of squares. Product of a sum and a difference. Okay, there we go. So there's our sum and our difference. Okay, right? That's what we're talking about. Sum, difference. Okay, so we're going to use an example here. We'll stick with x plus 3, but instead of x plus 3, what we were doing before with the squared, which gave us x plus 3 times x plus 3, we're not working with two sums, right? What we're going to be working with is a sum and a difference, so it's going to look like this. X plus 3 times x minus 3. So, to find the product of a sum and a difference of two terms, we're going to use the pattern. So there's a new pattern here. So what we're going to do is find the product of the first terms and then find the product of the second terms. Okay, so let's write that down. to find the product of a sum and difference of two terms we're going to use the pattern. So we're going to find the product of the first terms and then we're going to find the product of the second terms. All right. So if we use our example up here, x plus 3 and x minus 3, we follow step 1, then we're going to get the product of the first two terms. So I've got x times x is x squared, and then the product of my last terms, or my second terms, is positive 3 times negative 3 is going to give me negative 9. Now, I'm going to show you this broken down using distributive property, so you can see how we got to x squared minus 9. So let's go ahead and do it. So we've got x times x is x squared. Then I've got minus 3x plus 3x. And then, now, I know your inclination here is to write minus 9, and that is correct, but what I do want to show you is minus 9 is also equivalent to minus 3 squared. That's where we get this whole difference of squares, right? Difference is the subtraction and then of squares. Negative 3x and positive 3x, those cancel out completely. And then if I simplify it further, I get x squared minus 9. So hopefully seeing that broken down in the steps lets you visualize a little bit better what's taking place when we just use the patterns and come to our product in this way. So our result here is a difference of squares. Okay, so let's apply these special product patterns. Before we jump into a word problem, let's just expand and simplify to start. So here we've got, let's say we have x plus 4 squared. Okay, so look back at your steps for using the patterns to square a binomial. Okay, step 1 is I'm going to square the first term. So I'm going to get x squared. I see it's a plus, so I know my second term is going to be plus. All right, then I'm going to multiply my terms together in step 2. So I'm going to get 4x, and then I'm going to multiply that by 2. So I'm going to get 8x, and then I'm going to square my last term. I'm going to get 16. Let's try another one. Let's do k minus 5 squared. Okay, step 1, square the first term, k squared. I know in my brackets I see a minus, so I know my middle term is going to be subtracted. Then I am going to multiply my terms together, so I'm going to get 5k, and then I'm going to multiply that by 2, which is going to give me 10k. And then I'm going to square my last term, which is going to give me plus 25. Let's try doing the product of a sum and a difference now. Let's see, I have q q minus 11 and then q plus 11. So if we use the pattern and just follow the steps, we're going to be able to get our difference of squares. Here this is our perfect square trinomial, right? And now let's see if we can get a difference of squares. So when I'm using the pattern, I am going to find the product of the first terms, which is going to be q squared, and then I'm going to find the product of the second terms. So negative 11 times 11 is going to give me minus 121. Let's do one more of those. But this time let's flip the signs around. So we've got 4m plus 3n, and then we're going to have 4m minus 3n. Okay, so let's use the pattern again. I'm going to find the product of my first terms. So I've got 4m times 4m. So 4 times 4 is 16, times m is m squared. And then I'm going to find the product of my last terms. I know it's going to be minus, because we know these are going to be our difference of squares, and difference means subtract, right? So, and then I've got 3n times negative 3n is going to give me negative 9n squared. Let's try a word problem. Okay. The radius of a circular helicopter landing pad is increased by 3 meters, and they want us to find a simplified expression for the area of the new circle. Okay, so we need some prior knowledge here, which is how to find the area of a circle. Okay, so an area, the formula for area of a circle is pi r squared. Now, we know that let's use our colors here when we're breaking down a word problem. The radius is increased by 3 meters. So, how can I write a simplified expression for the area of this new circle? So, let's call this I'm going to call it ANC actually, sorry, for new circle. Okay, so the area of the new circle is equal to, pi hasn't changed, but my radius has increased by 3 meters, right? So what can we do now? Well, we can deal with what's inside the brackets, because we can square this binomial. So I'll continue to bring down my pi. So if we follow the steps from the patterns for squaring a binomial, we're going to square the first term. I see that it's positive, so I'm going to know my middle term is positive. Then how do I find the middle term? Well, I find the middle term by multiplying the terms, so 3r, right? And then I multiply that by 2. That's going to give me 6r. And then I'm going to do my last step, which is to square my last terms. So 3 squared is 9. And now I can apply the distributive property to fully expand this. So I'm going to multiply everything inside the brackets by pi. So I'm going to get pi r squared plus 6 pi r plus 9 pi. So it's really important for you to be able to recognize when you are squaring a binomial, right? Because then you can just use the patterns to help you do that, as opposed to rewriting this whole thing out in this way. You can pause the video here and you can try and use the distributive property to see if you come to the final answer.